we have reached the end, our final objective of Unit 1, and its least common multiple for a set of numbers. And let's dissect multiple a bit, because when we talk about greatest common factor, I did say that factors and multiples were related, but they're different. They're oftentimes confused. We talked about, especially folks in my lit class, that factor has that FAC. That's the Greek Latin word for to do or to make. So factors are what makes a number. So we talked about the factors of 12 are 2 and 6 and 3 and 4 and 1 and 12. They make 12. Okay? Define for me a multiple. How's a multiple different?
Something that goes into that.
Not quite. Yeah? Something that you multiply to get to it, okay?
It's something that the number goes into.
Something another number can go into. Those are all good. Okay, James?
Numbers, so like a multiple of 12 is probably like 24 because 12 goes into 24.
Right. When you think of a multiple, this is not a formal definition at all, but I think it's good just to help kids remember it. Yeah.
It keeps going.
It keeps going, right? And I'm going to get to that just a little bit. When you think of a multiple, think of skip counting. 12, 24, 36, 48, right? 2, 4, 6, 8, 10, 12, 14, so on and so forth, okay? And when we look at, and we'll get to this in Greek and Latin eventually, that word multi means what?
More than
Many.
one.
More than one.
Not only more than one, but many, right? And as Lucy said, these multiples, they keep going. There are many, 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 many of them because in theory, our number system is infinite. There's no limit to the multiples a number can have. If I start counting by fours, 4, 8, 12, 16, 20, 24, those are all multiples of 4. I'm never going to be able to stop because numbers go on forever. Okay? So you've got some hints within the words that kind of help explain what they are. So for factors of 12, we've already listed these. You've got 1, 12, 2, 6, 3, and 4. They make 12, right? And then for multiples of 12, skip counting by 12s, 12, 24, 36, 48. And so on and so forth. Okay? And there really is no end. Right? So one way to kind of think about this is like,
excuse the interruption. Classrooms, please wait until you're called on for the pictures. Please do not come down until you're called. Thank you.
if I ask you for the greatest common multiple, why is that a silly question? To find the greatest common multiple of two numbers. The greatest common multiple is.
Because it's not possible.
It's not possible, right? Because numbers go on forever. So there is no greatest common multiple. That's why we have least common multiple. And it's tricky because you see that word least and you think of, oh, something small, like 1, 12, 2, 6, 3, or 4. You don't think of something that can get bigger because least means smallest, right? But the reason why it's a least common multiple is because the fact that they can go on forever, we want the first one, the first common multiple in both sets. Okay? You learned about this last year. Is light bulb starting to flicker?
About.
Yes.
They're already
Yes.
about.
Already on, shining bright.
Yep.
Very good.
Mine's not a lighthouse.
Okay. All right. Like 3 skeleton key. Okay. So there are two methods we're going to talk about. We're going to talk about the listing method again, okay, which is the one you probably learned last year. And we're going to talk about the table method as well, which I don't want you to confuse with the greatest common factor table method because they are quite similar. So you can pick which one works best for you. But let's use 6 and 10. And we're going to find the least common multiple by using the MCL method, basically backwards. What are the multiples of 6 and 10? Start listing multiples of 6, please.
2.
2 is a factor, right? Multiples means skip counting by 6s. So 6, and then I heard 12, and then 18,
24.
24,
30.
30,
36.
36,
48. 42.
42, 48, 54, 60. How do we know when to stop?
Because it doesn't matter.
Right, we really don't know when to stop.
It's 30.
Okay, so we just kind of list a few. I usually go out to 10 of them, and then we go to the next number and see what happens. Okay, so multiples of 10, 10, 20, 30, 40, 50, 60, 70, and again, they continue on as well. Okay, now we've got some folks recognizing where we're headed here, but once we've listed the multiples, C stands for common. What are the numbers that appear in both lists? Both have a 30. Both have a 60, right? What would the next common multiple be? If the first one's 30, the next one's 60, the next one will be 90, and then 120, and then
160.
150, and then
180.
it keeps going forever, right? Which is why we want the least of the common multiples, the first one that shows up in both sets, and that is 30.
Oh, I get it. I remember.
Okay, that is 30.
Is 30, is that like in the,
Oh, yeah, we did do this.
is that in the least, or does that go on the end and just run another one?
No, 30 is the first number that shows up in both sets.
Okay, so that would be in the L category?
Yes. Yes, that is the least of the common multiples. Okay? The table method now, again, similar to greatest common factor, we've got 6 and 10. So we're going to make our table with 6 and 10 here. Okay? This again. And just like greatest common factor, we want to pull out a common factor that the numbers have. So what's a common factor of 6 and 10? 2. So it starts exactly the same as GCF does, which again can kind of make it a little bit confusing. But we're going to divide by 2, and we get 3 and 5. Okay? Are there any more common factors between 3 and 5? No. So if we were finding greatest common factor, our answer would be 2, right? But we're looking for least common multiple, which means we need the L. The L means we take the 2, but we also multiply by our leftover factors, the 3 and the 5. See how that's an L? Isn't that clever? L. L. Yeah. L. Right?
Like Bugs Bunny.
And so our least common multiple is 2 times 3 times 5, which is 30. Okay? So the table method can be tricky because it's basically the same process as greatest common factor. The only difference is when you're all done, you take the L. Okay?
I don't want to take a number.
For least common multiple. Well, you do if you want to pass this objective on the test.
I'm gonna get
Take
some
the L.
other classes.
It's a strategic L, right? No? Okay. How are we feeling?
Tired.
Okay, I was
Shakes.
more talking about how we feel about this. Math.
Oh, good.
Okay. Don't pack up yet. We're not quite done. We've got 7 minutes left. Doesn't look like we'll be called for pictures quite yet. So here we go. Looking at 15 and 21. Let's do the table method first. Okay. Write our 15. Write our 21. Make our table. What is a common factor between 15 and 21? 3.
3 divided by 3.
So that goes there. We divide 15 by 3, divide 21 by 3, and we get 5 and 7.
We have to take the L.
That 2.
That's a 21.
That's 21.
Are there any other common factors between 5 and 7? No. So what do?
Take the L.
We take the L. Okay?
Is the answer 105, James?
Did you get the ballot passed in that season?
Hey, guys, come on, we're recording it, let's go. Taking the L means that we are taking that common factor, but also what's left over. And our answer, our least common multiple, is going to be 3 times 5 times 7, which is 105. Okay? So the table method, you can find both the GCF and the LCM depending on what you do in that last step. If you only take the common factor, that's the GCF. If you take the L for least common multiple, that's the LCM. Yeah.
Do you have the same numbers on the test then?
I just thought about doing that. That might be brilliant. Or it might not be. I haven't decided yet.
I think
It's
brilliant. You should do it.
Yeah.
If we list the factors, if we use the listing method for those that are like, I don't want to mess with my GCF table, I understand that well, I don't want to mix up the two, you can list them 15, 30, 45, 60, 75, 90, 105, 21, 42, 63, 84. We see that 105 shows up in each list. Okay. Of course, what's the risk with the listing method though? Gigi? Yeah, if you add wrong, if you put 110 here instead of 105, well now your whole list is messed up and you might not find a least common multiple for a long time. Okay. So it's a little bit less risk to use the table method, but this method does work as well. Hey.
Can I answer the next one?
Hold that thought, but yeah, we'll come back to you. Yeah.
You want to use a calculator?
You can use a calculator on this objective. Okay? So you will have that advantage. Next one. Aiden, what do you come up with?
You do the table for 9, 15, and 18.
Oh, you want to use table method?
Yeah.
Perfect. 9, 15, 18.
And then you goes in all of them.
3 does?
Yeah.
Okay.
And then you get 3, 5, and 6.
No, 3. Okay.
You take the L, you multiply them, and you get 270.
So here's another quirk with least common multiple, is that you only take the L if nothing goes into any of the factors you've got left over after this division. There's nothing that goes into 3, 5, and 6, but what goes into 3 and 6? 2. No. 3. 3. So in this case, you would go further by dividing your 3 and 6 by 3. Not the 5. And so that gives you a 1. Your 5 just drops down and you get a 2.
So then you take the L on that.
Then you take the L. Okay? You only take the L when you've completely exhausted all common factors. Even though 3 does not go into 5 evenly, because it's least common multiple, and again, this is another difference from greatest common factor, because it's LCM, we have to divide one step further with the 3 and the 6. Okay? Yeah, Schlafer.
Would it be 2 3s that you would do the multiplying with since we use?
Yes, so then taking the L, there it is. You've got 3 times 3 times 1 times 5 times 2. All those numbers go in there, and what do we get? What's 10 times 9? 90.
I didn't know you said that. Oh, well that still turns out to be the same thing.
Yeah, 90.
Aiden got 270.
70.
Yeah, and the reason why he got 270 is because 90 times 3 is 270. He left that 3 in there. We didn't divide it out.
Did Mrs. Dawson call you?
No. There's nothing she did. I didn't hear my phone. I don't believe so.
Did she call you? 7th grade maybe going last.
What?
Wow.
We have gym. Yeah, we have gym.
Jim will probably be inside then. So.
Bro, we all like sharing the half of the
Hey, we are No, it'll be in the classroom probably.
here, I
Yeah,
would
computer science, right. It's flexibility, okay?
It's not
If things always went the way they were exactly planned, life would be so boring.
Just like
picture it last.
Yeah.
why can't we go outside instead of having gym and not
Like,
I don't know.
the one time we had
Right, so Mrs. Griffith's schedule, today is when she has you for gym, and she can't adjust that because she's missing another class. Flexibility, people, flexibility, it's okay, it'll work out, it'll work out.
hair is gonna be curled.
Here, oh, good, I will give you homework that you can work on when you're inside the gym.
I mean, if you're doing computer
No,
time, I may as well go with God.
I didn't say yes.
Can you work on the first one, 3 and 8?
What's that?
You guys don't have to.
So 3 and 8, that first, are you thinking of the table method?
Yeah.
Yeah, so Enzo's noticing that on the next one, that 3 and 8, right off the bat, there are no common factors for 3 and 8. So what do you think you do? If there are no common factors for 3 and 8, you take the L right away, which actually just looks more like this, because that's all you have. But you multiply 3 and 8, and 24 would be the least common multiple. Okay? For homework, for Monday, now don't start yelling. For Monday, I want you to do just page 14 of CO6. Okay, just page 14 of CO6. We'll deal with the word problems like we do with GCF. We'll deal with the word problems on Monday. All right? Questions, comments, concerns, complaints, public expressions,
Complaint.
about that.
Yeah,
What's your complaint about math?
I don't want to do homework.
That's how math.